Morning students, let us start with today's lesson of some basic concepts of chemistry. So students will be able to do some mathematical operations like multiplication, division, addition and subtraction on numbers expressed in scientific notation. Today we are going to discuss about scientific or exponential notation and dimensional analysis, conversion of a physical quantity in one type of units into some other units. So let us begin. So first of all, scientific or exponential notation. In the study of numerical data in chemistry, we come across very large values or very small values. This is because chemistry deals with atoms and molecules which are very small in size. Hence, there may be a very large number of atoms or molecules in a small amount of the substance, whereas the masses of the atoms and molecules in gram or kg are extremely small. For example, suppose Avogadro number of particles is equals to 602.213670000 and so on. So particles. So similarly, hydrogen atom, mass of hydrogen atom is equals to 0 point of so many zeros and then around 14 and 166 grams. So as representing the values in this manner is not convenient, means writing 000 is not very convenient. So we express such values in scientific or exponential notation, that is in the form of n into 10 to the power n, where n lies between 1 to 10 and capital N lies between 1 to 10 and small n is the exponent, which may be positive or negative. Let us take some example. For example, first is 4683.507. We can write it as like 4.683507 into 10 to the power 3. That is, decimal is moved 3 places towards left, so that only one non-zero digit is left, and the number of places moved, that is 3, is the exponent of 10 in the scientific notation. So ultimately we are getting 10 to the power 3. So another example, suppose we are taking 0.000256. So how we can write this in scientific notation? As 2.56 into 10 to the power 4. That is, here the decimal is moved 4 places towards right, so that there is only one non-zero digit before the decimal point, and the exponent of 10, that is minus 4 in the scientific notation. So ultimately we are getting 2.56 into 10 to the power 4. So thus value of Avogadro numbers will be given, which we discussed, is we can write it as 6.022 into 10 to the power 23, and when expressed to 4 significant figures. So similarly, mass of hydrogen can also be written in terms of scientific notation as 1.66 into 10 to the power minus 24 grams. Now let us see how calculations are carried out with numbers expressed in scientific notation. So calculations involving multiplication and division. So these two operations follow same rules which are used for exponential numbers. In multiplication, the coefficients, that is the number capital N before the factor 10 to the power small n, are multiplied, and the exponents of 10 are added up. So for example, you can see here the images being given. So first question is 5.7 into 10 to the power 6 multiplied with 4.2 into 10 to the power 5. We have to do multiplication operation in these two numbers expressed in scientific notation. So for doing that, first of all, we are categorizing 5.7 into 4.2 multiplied with 10 to the power 6 into 10 to the power 5. So we can write 10 to the power 6 into 10 to the power 5 as 10 to the power 6 plus 5. and by multiplying 5.7 into 4.2, we are getting 23.94. So ultimately we are getting the answer 23.94 into 10 to the power 11. We have added here the exponents given 6 plus 5 because we are knowing that in multiplication the exponents are being added up. Exponents of 10 are added up. Similarly, second question 5.7 into 10 to the power 6 in multiplied with 4.2 into 10 to the power minus 3. Again here the numbers are same but the exponents are different, 10 to the power 6 and 10 to the power minus 3. So when we are going to add up the exponents, 6 plus of minus 3, we are getting 10 to the power 3. So we are getting the answer 23.94 into 10 to the power 3. Again another one is we have taken the same numbers for multiplication, but again here the exponents are different. Here we have taken exponents 10 to the power minus 4, 10 to the power minus 2. So again we have to add upon both of them. So by adding we are getting 10 to the power minus 4 plus minus 2. Then we are getting answer 23.94 into 10 to the power minus 6. Now some examples of division. In division, the factors capital N are divided and the exponents small n are subtracted. Like you can see, for example, here the questions are, first question is 5.7 into 10 to the power 6 divided by 4.2 into 10 to the power 3. So when we are going to divide both of them, we are getting, after division the numbers, we are getting 1.357 multiplied with, when we are going to divide 10 to the power exponents of something, 10 to the power 6 divided by 10 to the power 3, then here we have to multiply the subtract the exponents. So 10 to the power 6 minus 3. So we are getting ultimately 10 to the power 3. So 1.357 into 10 to the power 3. Again in second example, you have seen that 5.7 same question is being taken, only the exponents are different, 10 to the power 6 into 10 to the power minus 3. So we have to divide both of them. So for division, when we are dividing means 10 to the power 6 minus of minus 3. So we are getting minus of minus means plus. So we are getting 10 to the power 9. Similarly in question 3, again exponents are different, 10 to the power minus 6 and 10 to the power minus 3. So when we are going to divide both of them, we are getting 10 to the power minus 6 minus of minus 3. So ultimately we are getting answer 1.357 into 10 to the power minus 3. So now some calculations involving addition and subtraction. So for these two operations, first the numbers are written in such a way that they have the same exponents. Means for doing the addition and subtraction, the numbers should be numbers in the exponent should be same. So taking out 10 to the power n common, the coefficients are added or subtracted. So let us see some example.
Suppose, let us take one example on the calculations involving addition and subtraction. So first of all, let us take one example, 4.56 into 10 to the power 3 plus 2.62 into 10 to the power 2. So we have to add upon both of them. So for adding, first of all, we have to make the exponents similar so that we can take out the same exponent common and then we can add up. So first of all, we can write 4.56 into 10 to the power 3 as 45.6 into 10 to the power 2. After shifting the one decimal to this side, we are getting 10 to the power 2. So again, we can again write as 2.62 into 10 to the power 2. So now both the exponents are same. So after that, we can take out common 10 to the power 2, and after taking out common, we are getting 45.6 plus 2.62 into 10 to the power 2. So after adding up, we are getting 48.22 into 10 to the power 2. So this is the addition. Suppose we are taking one more example. Suppose we have taken for subtraction 4.5 into 10 to the power minus 3 minus 2.6 into 10 to the power minus 4. So suppose we have to subtract both of them. For subtraction, first of all, we have to make again both the exponents similar. So for making both the exponents similar, what we have to do, we can write it as 4.5 into 10 to the power minus 3 as it is, and then minus of, suppose we have to change this very exponent to minus 3. So for changing, we can write it as 0.26 into 10 to the power minus 3. So now the exponents are similar. So taking out the exponents common, we can write it as 4.5 minus 0.26 into 10 to the power minus 3. So what we are getting? 4.24 into 10 to the power minus 3.
So now let us proceed to the next topic, that is dimension analysis. So what is dimension analysis? Any calculation involving the use of the dimensions of different physical quantities. So first of all, first is the thing is that to convert a physical quantity given in one type of units in some other units, means we are doing conversion here from one unit to another unit. So the method used is called factor label unit method or unit factor method. So it consists of the following steps. The first step is that first of all we have to determine the unit conversion factor. For example, for conversion of pounds, LB we are writing pounds as LB into kilograms kg or vice versa. So 1 kilogram is equals to 2.205 LB. So therefore we can write 1 is equals to 2.205 LB divided by 1 kg, or we can write 1 is equals to 1 kg divided by 2.205 LB. So this is the unit factor method, unit conversion method. So similarly, for conversion of inches into centimeter or vice versa, 1 inch is equals to 2.45 centimeter. This should be given to you. So therefore we can write it as 1 is equals to 2.54 centimeter divided by 1 inch, or we can write 1 is equals to 1 inch by 2.54 centimeter. Means the quantities such as 2.205 lb per kg or 1 kg per 2.205 lb, or for the second one 2.54 centimeter per inch or 1 inch per 2.54 centimeter are called the unit conversion factors. These are the unit conversion factors. So the basic principle involved is that if some number is multiplied by these unit factors, that is 1, it will not be affected in the value. So second one is multiplying the given physical quantity with the unit conversion factors, retaining the units of the physical quantity as well as that of the unit conversion factors in such a way that all the units cancel out, leaving behind only the required units. If the unit conversion factor has not been used correctly, the answer will come out to be in a wrong units. Means units may be wrong if you are not going to do the correct conversion. And the last step is, if the conversion involves a number of steps, each conversion factor is used in such a way that the units of the preceding factor cancel out. So for understanding these rules in more details, let us do some examples. So question number 1, you can see over here, a man weighs 175 lb. Express his weight in kilograms. Given that 1 kilogram is equals to 2.205 lb. This been given to you. So for converting it, we are knowing that 1 kilogram is equals to 2.205 lb. So therefore, we can write it as 2.505 lb is equals to 1 kg. So when we have to write, we can also write it as 1 is equals to 1 kg upon 2.505 lb. Okay, or here you are seeing that 1 lb is equals to 1 kg by 2.505. That lb is going to be in denominator. So therefore, ultimately we can convert the last one is 175 lb. We are knowing 1 lb is how much? So now we are writing 175 lb is equals to 175 lb multiplied with the unit conversion factor, that is 1 kg by 2.505 lb. Now lb is getting cancelled units. So we are getting our answer as 79.4 kg. So moving towards next one is in solving problems. For this purpose, units are written along with all the numbers. The units are then cancelled in the same manner as the numbers. If the problem has been correctly solved, the answer will have correct units. So let us discuss one more example. The question is like this: how many inches are there in 3 kilometers? You have been given 1 kilometer is equals to 1000 meter, 1 meter is equals to 1.094 yard, and 1 yard is equals to 36 inches. You've been given these things and you have to convert 3 kilometer into inches. So initially you are knowing that 3 kilometer is equals to how many meters? First of all, we have to convert it into meters. So 3 into 1000 meters. Now, for we are having meters, so 1 meter we are knowing 1.094 yard. So for converting meter into yard, we are again multiplying 3000 into 1.094. This is the total amount of yards we are getting. So after getting the total number of yards, we have to multiply it with 36 inches. Then we are getting our answer in inches. So therefore, we can write 3 kilometer is equals to 3 kilometer multiplied with 1000 meter by 1 kilometer in order to cancel out the units, multiplied with 1.094 yards divided by 1 meter in order to cancel out the units, multiplied with 36 inches by 1 yard. These are the unit conversion factors. By multiplying these unit conversion factors, we are getting our answer 1.18 into 10 to the power 5 inches. Why in inches? Because here you are able to see that all the units are being cancelled out. Kilometer, kilometer, meter, meter, yard, yard. So we are getting our answer in correct unit, that is in inches. So this is the conversion by unit factor method. So these are some useful conversion factors you can see from here. The first one is from a given unit to another unit. Some units of length are given, some units of mass are given, conversion units, some conversion units of volumes are given. You must be getting these all things in your books. And in B part, from given unit to SI unit, means from a given, what suppose first one is 1 angstrom. So how 1 angstrom is equals to 10 to the power minus 10 meters, and meter is the SI unit of length. So like this, there are some useful conversion factors are given. So today we have discussed about scientific notation and dimensional analysis using unit factor method. Thank you, students.